In this video presentation, I will be solving a problem which is using the concept of law and parallel curves in order to uh, generate two surfaces which are relatively complicated and then blend them together. Now, it is the playlist that I'm working on is intended for people who want to transition from the Catia V5 to 3D experience. So I try to find problems that are already done by others using Catia V5 and show you how this can be actually worked out when you go to the 3D experience platform, whose interface is completely different from the Catia V5. In fact, the CAD workhorse for 3D experience is Catia V6 and not Catia V5. The particular problem that I'm looking at is has been done by this professor at Central Michigan University, and but using Catia V5. So I'm going to replicate that in 3D experience. The situation is as follows. We have two curves here, two curves. One of them is sinusoid, like that, with a frequency of uh, 3 pi here. And the other one is a negative cosine with a frequency of 4 pi and 4 pi radians per second. But anyway, these are not these are not time, but I just want to show you how this works. The fact that you have 3 pi here means that you have three bumps. The fact that you have 4 pi means that you essentially have four bumps. So first we want to generate these curves, and once we generate it, then we can do an extrude, and then once we do an extrude, we can blend them together using the blend option. These lines are each 6 inches long, and the two lines are 10 inches apart. Keep in mind that when you go to the source, these numbers may be different. For example, the fellow may be using millimeters, and so they're not identical. All right, so the idea is to use the law, but not any law, because we want to actually type these formulas exactly like it is, and therefore the law that we're talking about is in 3D experience is, is it has this icon, okay, which is the counterpart of that guy in Catia V5. Okay, so let's go ahead and first of all create these two lines. Let's go to 3D experience. Here's the interface. Okay, uh, we already have a plane here, so I'm not going to create an axis system. This gentleman has created an axis system. I'm not going to do that. So on that sketch, on that plane, I'm going to sketch a line that is 10 inches long, not 10 inches, 6 inches long. Let me, yeah. uh, Okay, 6 inches long. So from here to there, let's make this thing 6 inches. 6 inches. Very uh, okay. Let me uh, let me actually bring it and coincide with that. Although that's really not necessary, but anyway, I'll do it so that it pretty much looks like what this fellow is doing. Coincide. Okay, good. Exit. So there is my line. Uh, yeah, that's fine. That's fine. And then I'm going to create a, a plane that's 10 inches away from this guy. So 10 inches away from here. We are in generative shape design, by the way, 10 inches away. Okay, and then on that plane, I will sketch, well, pretty much the same thing. So I'm going to go from here, there, and make sure it is 6 inches long. once again, yeah, that's actually, so I want this to be coincident with that. Control that point, control this. Okay, how about here, let's put a dimension there, from here to there, 0. Okay, good. Exit. I don't know why I made it so complicated, but anyway, I want two lines which are in these two planes, 6 inches long, etc. Okay, good. So now we're going to go, we need to find this fellow, right? So here's a situation. You go to transform, go to essential, sorry, you go to transform, yeah. Now that is not what I have here, okay? So this is a law, but it's not the one that allows me to write, formulas. And so what you go to tools, now when you go to tools, incidentally, let me make this thing bigger so that they all fit here. When you go to tools, you don't see that law. That's because there's a triangle here. If you click on it, you see that? It shows you the hidden stuff and it's right there. Law creates here, this, right? So you click on that, law number 1, that's going to be the one which has 3 pi in the formula. Okay, good, good. So let's create our length parameter first. New parameter of type length. These are formal parameters. I have to do it. So I'll call it x. How about that? X. And another one, but that's going to be real, of type real. Click. And it's going to be t. Apply. And now we're going to type our formula. In other words, x equal to, don't forget the units must be consistent to inches. X is length, my units are inches, so this has to be 2 inches, times sine parentheses 3 times pi. A pi, you can use it in 3D Experience, just like big P, big I. Okay, that represents 3.1415, etc. And then times, the unit must be in radians, 1 rad, times time. And not time, t. This has nothing to do with time. So this is my first formula, my first law. Hopefully there are no syntax errors. Yep, good. It's right there. You see that right there. Okay. And then the second one, you click on it. Law number 2. And this is going to be, once again, I'm going to create 2 parameters. One of them is, I'll call x. This is just a local variable. It doesn't matter that there is another x that I already used. You can call it y, z. It's totally local. This is okay. Let me call this thing t because it's already type real. So you apply. There we are. And now change this thing to length. Click on it. I'll call it x of type length. Apply. Good. And now I can go and type my formulas. So x equal to negative 2 inches times cosine parentheses, I think this was 4 pi, 4 times big P, big I, times 1 rad, 1 rad. Okay, good. Did I miss something here? 1 rad, it's too small, but that's okay, times the parameter t. T, and then close it. Okay? You say okay. So we have two laws here. All right. So let's do the following. Now we're going to go to wireframe. Here is this is projection. I don't want projection. I want this parallel curve. You click on it. It says, what is the curve? The curve, the one with the 3 pi radian goes here. This is the curve. What is the support? The support is that plane, XZ plane that I had right here. And I'm using a law right there. See that? This icon, see? Law. You click on it. It says, where is it? Well, it's a law that I actually typed, right? So it's not constant, linear, S type, etc. It's advanced. It says, where is it? Well, it's right here. I typed it. And this is the one with, notice that this is the one with 3 lumps, okay? And then we say close, and then okay. And here it is, okay? Now we go and do the other one, the other parallel curve. Parallel curve, the line is right here, or the curve is right here. The support is that plane that I created, and this line sits in it. And the law is right there. You click on this, you see that? Law. And it's the advanced law. It says, where is it? Where is law number 2? And this is the one with 4 bumps. You say, okay. And then we say, okay. There we are. Okay, so let's go and create our extruded surfaces. So we go to surface. Here's extrude. Let's do this one first. Yep, that's fine. That's fine. Let me make it a little bit longer. Maybe 2. Okay, fine. And then extrude this guy. Okay, that's fine too. That's fine. And then we want to blend them. Now, where's the blend? Let's see if we can find a blend here. This is sweep. There is something called blend here. Let's see what else do we have here. Uh, essentials. I think this is the blend, right? Yep. Under the essentials tab, this is the blend. And read it carefully. It says first curve is this curve, and the support is that support. Second curve is the one on this side, and the support is that support. And let's see how it goes. There we are. So this is what you see there. Okay. And this person has done it. This professor has done it with Catia. That's pretty much it. So before, in passing, notice that uh, I could have, instead of using uh, the actual formulas, I could have done the interpolation with splines and things like that, which is essentially the tutorial number 11. I advise you to take a look at it, and then you could have done the same thing without actually, and if that's the case, then you're not going to use this guy, but you use the standard law, which is in the transform section right there. There is no f of x on it. Yep. Good luck.